Hello and welcome. I am going to play a particularly wild case today. This is the final case from the finals of the MEWC UK Championships 2025. It's called Malice in Wonderland, written by Harry Gross. I don't know how much of the backstory of this got told on the day because I haven't had a chance to watch the whole stream yet. But Malice was originally developed like almost a year ago, like right at the start of the year, to be the second the second free case for MEWC UK, and then it was deemed too hard for that and reserved for the finals, which is why Harry and I, in a bit of a rush, wrote All's Well That Ends Cell/Excel, and that became the second free case instead. But that's how long this one has been in the works. I haven't actually, so I did a test solve of it at the time, and it definitely melted my brain. And some things were, I think, simplified a little bit from there, although not that much. Um, but I haven't properly looked at it since then. So let's dive on in. I should say there are definitely parts of this that can be kind of manually solved. I'm not going for a speed solve. I'm definitely going to try and be relatively pure of doing things by formula. But all right, let's dive on in. Prologue. Alice, a young woman from Oxford, should probably cut down on the drugs. I remember that. She's spotted a strange white rabbit across a field, and the burrow he's headed to is very deep indeed. Alice will plummet down the rabbit hole into a strange scene called Wonderland, a paradoxical place plagued with malice. Your goal is to help Alice escape with her sanity intact and to make Wonderland a better place along the way. Be careful, as people have been known to lose their heads in Wonderland, and those who do return are never quite the same. Bravery is optional, but fear is not. The case has 7 independent chapters of variable difficulty, 6 riddles, and 1 point available in the epilogue. There are no dependencies between chapters nor riddles. They can be answered in any order. But I'm just going to go through them in the order they come. I do like this sort of table of contents type setup. Anyway, this one I don't think actually this one was labeled as like alarmingly hard. I don't think it was massively harder than all the rest, but I guess it depends on how pure you are about doing it with formulas. Anyway, we'll get to there. Okay, I'll do bonuses at the end. I usually do. All right. Chapter 1, very easy. As the white rabbit comes into view, it seems he's wearing a waistcoat and mumbling about the time. His sharp temper is caused by his faulty pocket watch, which needs realigning. To calm the white rabbit down, Alice offers to help him adjust it. How many minutes forward will Alice have to adjust the white rabbit's pocket watch to align with the actual time? If the time needs to be adjusted backward, answer with a negative number. Okay, so here we got to go backward. So I want to do, I guess, that time minus that time. We'll give it the right sign. And then that's the difference in days, so times 24 times 60 for minutes. Yes, happy days. Okay, Chapter 2. Alice has tumbled down the rabbit hole. She rubs her head and looks around, finding there is no way out of the room except for a locked door. She sees a series of liquids labeled Drink Me. With nothing else to satiate herself, she starts sipping, and to her surprise finds that the potions change her size. When Alice drinks wine, she doubles in size. When she drinks milk, her size is divided by 5, rounding up to the nearest whole number. She starts with a size of 72 and drinks left to right until she has a size of 1, at which point she can squeeze through the keyhole. How many drinks has Alice consumed when she squeezes through the keyhole? Okay. Um, so I'm going to start with regex extract. So I think that if I use, I should probably import my lambdas. I think if I use my regular letters lambda here, it will not work because these things are, yeah, these are, so if I just look at this milk thing is of length 2. So if I say mid of that 1, 1, which should give the first character, it gives that. And if I say mid of that 2, 1, it gives that. And if I put those two things together, it gives me that. So you can't do it the regular way, but I can do regex extract of this by period. Sorry, and then give me all of them. Or I suppose I could also use my letters, but take in length of 2 and split. And that would get the same thing. Okay, so I want to reduce, no, I want to scan, because I want to keep all the interim results starting from 72 through that, and I want to say lambda AV, and it's going to be round up A times if v equals now. Grab this text. So if it's wine, she doubles. Yes, wine, she doubles. So if it's milk, then it's 1/5. Otherwise, it's 2 to 0 decimal places. I think that's it. So she goes 15, 36. Yep, that looks right. So then we just want to X match 1 against that. 1 against that. And then we get 13. That's good. Okay. I remember this one well because, well, let me read it and then I'll tell you my story. Alice meets a caterpillar who is so upset about not being a butterfly that he visibly has smoke coming out of his head. He sees that Alice isn't a caterpillar or a butterfly. Explain yourself, he says. Drunk on wine, all Alice can say is, I can't explain myself, I'm afraid, sir, because I'm not myself, you see. The caterpillar maliciously decides to demonstrate she is wrong by tasking a game that requires implicit self-reference. Fill in all the answers. Example 3 in games 31 to 50 in a way where all the games have a valid answer. Note example 3 is included. For authentic experience, you may wish to attempt this chapter drunk. So, in other words, here you've got 16 answers. You have to choose an answer from these in such a way that you don't repeat it anywhere else. It's kind of like a giant Sudoku. I looked at this when I first solved it for a good while and thought this cannot possibly be sufficiently constrained. Like I laid out what would be the sort of giant Sudoku grid. The challenge was that I hadn't properly understood this. And also that these are deliberately put, I think the hint here actually tells you, my dear Alice, the caterpillar is cruel and has presented the first games to solve last. You might want to start at the end. If this does not ease your burden, perhaps skip to the next chapter and return later. Both sensible pieces of advice. So for some reason I was thinking of these needing to repeat up here, but of course they couldn't repeat up here because then these couldn't be the answer anywhere else in the chapter, which means that among these 4, you have to, the repeat has to come within this 4. So let me just show you a way to do this. I'm going to do this one not particularly formulaically because I know that there is a bonus. This bonus was my idea, linked to this level that will require you to be very formulaic. But for now, I'm just going to do some conditional formatting. So here, I'm just going to Alt-H-L-H-D to highlight duplicates, and then you can kind of immediately see, well, the only way this can repeat is with this, and the only way this can repeat is with this, and nothing else works. So that's 11, 13, 13, and 11. And then we can come up here, and we can say Alt-H-L, new, use a formula, and we're going to say count ifs is fine, I guess, and we're going to count all the chapter results is equal to that. And if that is 1 or more, meaning true, then we'll make it, I guess, orange. And, oh yeah, there we go. For a second I was worried that there wasn't one, but I think from here on it's basically a case of we just look at each. So like here you can't use 11 or 13, so this has to be 19, and then that fills in this one, so this now has to be 17, and yeah, now this one has to be 8, and then this one has to be 5, and this one has to be 15, and now they're starting to drop pretty quickly. This one has to be 10, which means this one has to be 4, and then this one has to be 12, and then this one has to be 18, and then this one has to be 3, and this one has to be 2, and this one has to be 6, and this one has to be 7. And those are the answers. Oh, wait, no, there's more. Sorry. This one has to be 16, 14, and 20. And those are the answers. Yeah, we'll come back to the formulaic version later. All right, chapter 4. Oh, actually, I just realized the hints are kind of slightly lols as well as just being hints. So let's see what else is going on here. Optional Hatter hint. Alice, my dear, depending on how you self-appreciate and excel, these bottles and glasses may constitute either 1 elemental character or each count as 2 mids. All right, yeah, that's a warning about the length. The depending on how you self-applicate and excel, I assume is a reference to you may have a version where you can switch to compatibility version 2, and then it treats those as being of length 1. And no Hatter hint for that one. All right, so let's keep going. Blah, blah, blah. Here. Okay. A bit annoyed at the caterpillar, Alice meets a cunning Cheshire cat, which is there, but also not there, except for his grin. A quantum physicist has maliciously locked the cat in a box to test one of his theories. Alice wants to help the Cheshire cat escape by telling a cat pun so bad that his grin becomes thin enough to slip through the seams. The quality of each pun is calculated as the total letter value. Capital letters are double points. Punctuations and spaces do not score points. Okay, so I think I'm going to go for a regex again because you can use /pl to mean any letter. And that, I think, will automatically, yes, strip the spaces and the punctuation. Beautiful, 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 beautiful. Then I want to take the code of that, I think. Yes. And now, if I mod that by 32, there's a trick I learned from Bo. So that the range, if I go A, B, C, and A, B, C, the range of codes of these, so the capital letters are 26 letters starting from 65, it goes up to 90, I think, and then from 97 up to whatever, 122 or something like that. But they both start at one more than a multiple of 32. So if you take them mod 32, then you get one for A and two for B and so on across, which is just what we want, except we want to figure out which are capital letters. So let's do this. We'll say let letters be that, and then we'll say vowels be this, and I want cap can be exact letters, upper letters, and show me cap. That seems to work. Okay, and then finally I want, well, let's just for a visual check, let's vstack vowels cap and vowels times 1 plus cap. So, oh, sorry, let's vstack letters and all that stuff. So we get a capital A, which is worth 2, a lowercase b, which is worth 2, an O, which is worth 15, and so on across. That seems to be working. So now we can just get rid of all of that stuff and sum that. Happy days. Okay. Chapter 5. Alice saves the Cheshire Cat, and in return he leads her to the Mad Hatter's tea party. He's spouting some sort of monkey-themed final riddle, she thinks. She feels far too afloat to solve it. I'll talk more about that final riddle later. But her tact and wit was still there strong, as well as the herbal tea she had so kindly provided. He had so kindly provided. To simultaneously assess her convulsing sense of perception and distract the Hatter from feeling let down, she challenges him to a game of I Spy. Okay. The Mad Hatter's Tea Party occurs on a named tab. That's right here. Pretty cool. And the RGB values to use for each cell are provided in the red, green, blue format. Use the provided values as they do not fully align with the true values. We'll come back to that in Riddle 2. For each of the colors below, find the cell address at the tea party that has the smallest absolute difference to the target color, i.e. the absolute difference of red plus the absolute difference of green plus the absolute difference of blue of the winning address is minimal. Okay, so if we look in here, each of these cells has the red, green, blue. So I think I'm just going to two-call. Actually, wait, is it? Yes, it is too long a string to put it all together, but I can by-row lambda row text split row by semicolon. Good. And that is my, I'm just going to name that RGB. Sorry, we want to multiply that by 1. I guess we can just do that once on the outside. And then we'll name that RGB. So then I want to say by row of absolute value of RGB minus text split of this by a semicolon sum. Oh, and I need to keep the addresses as well. Right, that would help. Okay, so equals to call addresses of all this. No, I do not accept your stupid correction. Okay, let's name that add. So then we're going to XLOOKUP 0 in all of that, returning from add exact match or next smaller item. What? That doesn't make any sense. Sorry, exact match or next larger item. Stupid. It's the little things that get you. All right, good. Chapter 6. Alice and her tea continue their atelic journey, drifting on from the Mad Hatter. Finally, somewhere seeming sensible, she ends up in the Queen's courthouse, where the Jack of Hearts is accused of stealing the Queen's tarts, but all playing cards are suspects. She watches the strange course of justice, where the King is using a process of eeny, meeny, miny, moe to select the guilty party. The King always starts by accusing the Jack of Hearts in the courthouse of cards. Let's bring that in. He then points at different cards in turn, moving his fingers following the given direction until he reaches the end, and then accuses whoever he is pointing at. If the king would move up when in the top row, he cycles around to the bottom row instead. Similarly, the leftmost column cycles to the rightmost column. Okay, so in other words, a left from here takes you to here, a right from here takes you back to there, up from here takes you to there, and down from here takes you to there, which is fine. Who does the king accuse? In example 5, after the following the first arrow, the king will be pointing at 7 of hearts, then okay. So first I'm just going to take a unique of letters of this. I don't know if these are all of length 1, but we'll soon find out if letters works. It does. Then I guess I'll just do rows and columns separately. So row, col. So this is -1, this is 1, this is -1, and this is 1. Okay. So then we're going to say let ours be letters of this. And say let row be XLOOKUP ours in here, lock returning. Actually, no, I can do them both together. So I just want to do choose rows of this. Lock by X match ours against this lock. And let's just return that for a second. That gives me that, and then I don't need to know all the interim steps, I just need to know where it ends up, so I can just say by call sum. And then where is it starts off pointing to the Jack of Hearts. Okay, so the Jack of Hearts is in row 1 and column 12. So that plus 1, 12. Now, the question is, can I do, actually, sorry, I don't want plus 1, 12. I want to make it plus 0 and plus 11, because that'll simplify the offsetting for mod. Now, so I'll just call that SH for shifts. So then the end is this SH plus that, and we want to do mod. I don't know if mod will allow me to give 2 different arguments, but so I want the rows to be mod 4 and the columns to be mod 13, and then add back 1. Whoa, that was so loud. Okay. And then give me end. That's 4 and 6, so that would be row 4 and 2, 3, 4, 5, 6. Should be the 2 of clubs. Is that the right answer? It is. Okay, hooray. So then we want to index on courthouse, lock. The row number is going to be at end, and the column number is going to be, I guess, index end 1, 2. Cool. Happy days. All right. Chapter 7. By this point, Alice was so off her head that even the Queen of Hearts, a big fan of guillotines — no, this isn't the French chapter — was impressed. She was so pleased with herself she decided to execute the Mad Hatter, but he had already lost his head, so she turned her attention to her subjects and declared, "Whosoever brings Alice's head will eat my tarts for a week. Off with her head." Oh dear, thought Alice, and ran into the maze to hide for her life. If Alice hides in these cells in the Queen of Hearts hedge maze, which card will see her? The playing cards see in direct line of sight, horizontally, vertically, but cannot see through walls. So, illustration here. The Five of Hearts can see up to there, down to there, right to there, and nowhere to the left because there's a wall right there. She will not be seen by multiple cards or start on the same cell as a card in this chapter. If her starting position cannot be seen by a card, write 0. There is exactly one safe spot in the answers, i.e. exactly 1, 0. Oh, I don't know. That might be changed from when I saw it. Note that the maze walls are cells and have been populated with a value of 1. Isn't the case author kind? I think that might have been at my suggestion. Well, that reminds me, I don't want to look at the Hatter text until I've done the level, but I think there was a Hatter hint here. King of Hearts does love his courting. Personally, I would not bother with the whole eeny meeny charade and just, okay, yeah, that's what I did. Just add up each arrow type. You don't have to take all the steps along the way. Okay, so this is the one where I was saying, I think Hayden already put up a video on this and said he just, you know, took each one and said, okay, this can go to here and to here, and, you know, basically filled in the maze like that. And, you know, there's some risk of error, but it's not huge. You could certainly do it. But I am a formula purist in some ways at least. So let's think about line of sight, which is always an interesting topic. So let's just first I'm going to start with this one and just do it this way. So I've got my usual. I convert addresses to row column references. So this is the 11th row and the 11th column. And then I've got the different ways you could go from there. So I've got my arrow offset codes. So let's flatten that to a row. And I'm only interested in the up, down, left, right, not the diagonals here. So let's just take 4 of those. I could have just really typed those numbers in, but whatever. And actually, sorry, this is not a great sheet to work on because half the rows are weird mini height to make it fit. So let's go do this somewhere else. Okay, so let's do it down here. We got space here. And then I don't actually want it 2 row. I want it like this. So this is where you start from, and these are the directions you can go in. So what we want is this, and sorry, let's just figure out how wide is the maze. 81. So the most steps you could ever take is 80. So we can say this plus 80 times sequence, oh sorry, plus sequence, comma 80, blah, go away, times that. And so these are the 80 different places you could get to by taking steps from each one of these. And then we can turn each of those into a reference on the map. So this is where you get to. And then we just want to go as far as the first one. So what is the smartest way to do this? I think if I do this, yes, that'll give them to me just as text, and then I can probably just by row concat, and then take text before 1, and concat again. And that would give me, this is the card that can see that position. So, and I think that would let, well, I'm saying I think that would let me solve the level. Why don't I just see if that does let me solve the level? And then we'll go on from there. So just put that in there, and then this can point to here. And I just need to say let A be that, and if, oops, if A equals blank, then 0, otherwise A. Because it said that you'll never be seen by 2 cards. So that, oh no, interesting. Does not. Gets a few wrong. Why is that? Let's look at BO29. Anyway, I was going to go and do it a different way anyway, but what? Why wouldn't you? Right, because of the 1 in the 10 of spades. Whoops. Okay, so let's be a little more careful than that then. So instead of concat, I guess, well, let's take this one out. Where is it? Here. Silly. I mean, I would have at least had a hint because he said that there was only 1 0. So I would have known that, I wouldn't have known which ones, but I would have known that some of the zeros were wrong and could have dug into it. But cautionary tale. Okay, so let's come back to this. Get rid of the text before, get rid of concat. Okay. So instead of concat, I think I want lambda row text join by, let's say, pipe row. That's better. And then I guess I want text before the first pipe. And then I guess I want to say let A be all that. And I want to say filter A where A is not equal to 1 and if empty 0. Okay. So second attempt, I think that will actually do it. Cool. But I don't love the amount of kind of redundancy of kind of calculating a line of sight for all 60 of these. I kind of want to be able to say, you know, this is what the map looks like filled in with all of these, but by formula. So now let's try that instead. So first things first, let's say to call of MP. That gives me all the 1s. I don't want that. So I've got to flatten. My condition is going to be MP not equal to blank, or not equal to 0, and MP not equal to 1. And header, I think I just want, wait, sorry, and there we go. So those are the locations, and then I also want to get the row column numbers for those. Okay. And actually, yeah, I really only need the row column number. So now I can take this this here. So I can say this plus that is going to give me a bunch of stuff, some of which I can't see. I'll just widen that one out and this one out so that I can see them. Then I want to ref. Sorry, I don't want to ref any of the. Yes, I do. I want to ref. Yeah. Of those on MP. Then I want. So I think I want to by row this. I want to say lambda row. I want to say take from row. How much? I want to say take X match 1 against row minus 1. Sorry, I don't want to take that many columns from each row. Oh, you didn't like that. Oh, sorry. 1 against blah, 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 2 ref of that on MP. Don't like that either? Really? Okay, lost a little bit of progress there from a crash, but we're back. So where was I? Oh yeah. So this, the -1, it can't handle the -1 because that would leave some rows empty. So that's fine. So we do that. Then I want to 2-row that with 3. So that's all the places that this card can see, and then I want to apply that to the whole thing. So we'll take this, and we'll say by row of this whole thing, lambda, I've already used rows, so we'll call it card start. Card start, close. And I'm going to get rid of that. And now, boom, these are all the places that all the cards can see. And then I want to take this. So I want to say let LOS, line of sight, be this. And CRD, card, will be the same thing, except I want to, instead of flattening out the addresses, I want to flatten out the list of cards. And then I should be able to make myself a little lookup table, which would be hstack to call line of sight by 3 with flatten based on line of sight card. Sweet. There it is. So now I should be able to say, let's take this whole thing, copy the formatting and the column widths. Oh yeah, now we can make these rows small again. So that's 2.2. So then we'll sort that, and then we'll call that LU for lookup. And then we'll say if MP equals blank, then XLOOKUP MP, row column of MP in take LU first column, returning from take LU last column, and match mode, no, search type, binary, because that'll go fast, and if not found, blank. And then if I take that whole formula and put it here, yeah, I think it worked. Wait, did it work? What's going on there? False? No, I don't like false. What's... Something's not quite working there. Anyway, I'm going to declare that close enough because I spent a long time on this question already. You basically get the idea. And then if I were to name this, oh, and actually, sorry, let's make this be otherwise 0, because that's what it wants to return. And then we'll just change the formatting so zeros don't show up. So we do 0 minus 0 dash blank. Okay. And then we'll name this MP fill. And hopefully we can get the same solution here by saying add to ref of these on MP fill by reference to the address in MP. Sorry, I need to move that a few arguments over. And let's see, and this equals this. True, hooray. Okay, bonuses. Sorry, riddles. What is the sum of the red RGB elements of the Mad Hatter's Tea Party? Use the provided color values which are formatted as red, green, blue. So you could do sum of text before of this before semicolon times 1. Or, since I've already created the RGB range, I could say sum of take RGB first column. Same answer. The Cheshire Cat watched over Alice and the Mad Hatter's Tea Party. He isn't visible in the cell formats, but he is visible if the provided RGB values were reapplied as colors. In which cell is the Cheshire Cat's nose? There are several ways to go about this in Excel. Please do not crash your PC. Okay, so I did this the VBA way. I took these and wrote some code to apply that cell, sorry, this RGB to each cell. And then Harry, in that way that he does sometimes, said, but there's a sneaky way to do it. And there is. So I claim no credit for coming up with this myself, but if we extract just one color and then make a scale, so this is our red, so let's, I guess, make it a red scale. We zoom out. You can see, let's just take the width from here. You can see that you basically reproduce the picture, except there's this anomaly here, which is the cat. And so, if we zoom in here, one assumes is these are like the ears and the eyes, and this little thingity here is the nose, and that is 15 steps in on row 90. So let's go into 15. So it is 090. Boom. And if you do actually recolor the whole thing, you get basically the entire picture back, except that these cells are white on all three colors. So you just get a white cat sitting behind Alice, which I thought was a pretty cool idea. Okay, if Alice drinks 100 glasses of wine in a row, starting from a size of 72, how many glasses of milk will she have to drink to reach a size of 1 or less? I think that Excel might be able to do this without, so like 72 times 2 to the power of, how many? 100, is, much bigger than Excel can compute without the zero errors. I think you would, I'll show you a different way, but I think you would probably still get the right answer if you said, okay, you got to divide this, size is not rounded, that's important for this one. So you got to divide this by 5 until you get below 1, which is basically just take the log of it to base 5 and round up. And sure enough, that works. But theoretically, if like 72 times 2 to the power of 100 was very close to a power of 5, then the cutoff digits might mess you up. So a different way that you could do this would be to say, just take logs from the start. So you'd say log of 72 plus 100 times log of 2. And you want to take all of that divided by log of 5, and again, round up. Have I got the right set of brackets? Yes, I have. That'd give you the same thing without getting into stratospherically large numbers. Okay, the last two are kind of the funkiest ones, so let's go with those. The king is corrupt. Assuming he always starts on Jack of Hearts and always moves 30 uniformly random directions before accusing someone, which heart card is least likely to be picked? Answer with the full card text. So, there is a sort of pure mathematical way to do this that Harry has partially explained to me. I kind of get it, but not with sufficient confidence that I think it would be the right way for me to solve this on a video. So instead, I'm going to show you an Excel way to do it. So let's get a grid of the probabilities of locations and let's evolve it. So we start off with, we are 100% definitely on the Jack of Hearts on the first step. Now, after that, we're going to have an equal probability of going in the 4 directions, which means you could end up with, let's say, VStack this with this. That's one possibility, so that's a down move. Then you could end up with, let's see, that's that one drifting down. So if you shift up, then it would be VStack all of this over this. That would correspond to an up move where you go from the Jack and wrap around to the bottom. And similarly, you could, with h stacks, construct a left and a right. And then if you take the average of all of those, that would be where you'd end up. So if we can get that down to a single lambda operation, then we can just apply that 30 times and we'll have the ending probabilities for every location. So let's do that. So let's let st, the start, be this. Then an up move would be vstack drop st, the first column, with take start off with take st, sorry, not first column, but first row. So that's what it would look like if you move up. And let's just put output up to check. And sure enough, yeah, you move up, the one wraps around to there. Okay, good. Moving on. Down will be very similar. But now, instead, we're going to drop the last one and take the last one and put it on top. I think that. And sure enough, that's a down move. Then left, I'll just make it LFT because there's a function called left, should be similar to going up. So let's try basing it on this. So instead of V stacking, we're going to H stack. And instead of dropping the first row, we're going to drop the first column. And instead of taking the first row, we're going to take the first column. And then I think that should work. And yes, that's a left move. And then similarly, right should be like down. So again, we'll change the V to an H, and we'll change the row references to column references. Oh, that one did not work. Oh, right, because I'm outputting 0. It would help if I output it right, and that is indeed a right move. So now we want to take the average of all of those, for which we can do, well, we could just add them up and divide by 4, or we could do map average. I don't have any strong feelings, so let's just add them up and divide by 4. Up plus down plus left plus right divided by 4. And that's it. So now finally I want to make that into a lambda. So we're going to say lambda st. That's my lambda. And then I want to reduce this by applying that lambda 30 times. So we'll say sequence 30. And I guess I have to make it lambda of 2 variables, although I don't use the second one because that's what reduce wants. And then close. And these are the probabilities for where I end up. So now I want to know the least likely to be accused heart. So I'll say let probs be that. Then what do I want? I want, I guess, hearts can be right of this equals, just grab a heart. So then I want to xlookup 0 in, I want to flatten my probs. Did I call it probs? Yes, I did. Flatten, sorry, no. Probs is what I want to flatten. My condition is hearts. And then I want to return from flatten, again based on hearts, this map. And I want exact match or next larger item. And there it is. I think that's the right answer, but just to give me some confidence, let's just have a visual look. Check can be H stack of these, and out can be this. And let's output check. And sure enough, yeah, The 7 of hearts seems to be the right answer. Right, so, where are we going? Yeah, instead of check, let's output out. And I just want to paste that there and then cut so I can get it over here without losing format. Hooray. Okay, finally, if the caterpillar does not ask the last... oh, sorry, you got to plug in. It's never simple, is it? It is never simple. Okay, where were we? If the caterpillar does not ask the last 4 games of Chapter 3 and Example 3 has a fixed answer of 9, how many distinct valid sets of answers are there to Chapter 3? If a single game answer is different between 2 valid sets of answers, they count as distinct. So, for this, I'm going to... let's text all of these. So I'm only interested in the first 16, and I just want them all to be of length 2 for now. So I'm going to start from, I guess let's just copy all of this. Yeah. Oh, whoops. Fine. So I'm going to start from this 9, and then I'm going to say, what can I add to that? So if it was here, then I could say those are now 3 distinct possibilities for the first 2 positions. There's a 9 in the first one, and then an 8, 9 and a 17, and 9 and a 19. But let's see, where is there a 9 down here somewhere? Yes, here. Let's say I went to this one. Then I would want to say that one of these does not work. And actually, sorry, I'm going to need some punctuation. So let's do and pipe and that. Boom. Sorry, keep that pointing up there for a minute. So now this one doesn't work because you've got a repeated 9, and the whole idea is you can't repeat. So I'm going to say if search for these in this, then give me that, and let's just make it ifs, and that'll make the last one be an error. Nope, sorry, wrong way around. So ifs is error. So that will take me from the 1 possibility for the first one to the 3 or the 2 or whatever. And then I just want to call that. This, by the way, if you've seen the logic before, it's because it's practically identical to the logic that Bo uses in Percom. So, you have a certain number of possibilities up to now in the form of multiple strings. To each of those, you add the new possibilities, and then you flatten it again. So let's reduce this through, okay, I guess through this array. Well, yeah, let's just start with a couple. Start with 1. And then we're going to say lambda AV to call if is error search text split of v by comma as 0, 0. Actually, sorry, we're going to use this again. So let's just make this a variable. So we'll say let, call it new nums be text split of that. Then we're going to say if is error search for the new nums in A, which is the old nums. Ifs that. Then I want A and pipe and new nums. And then I want to call that by 3. I think that's it. Yeah. So then you can say, okay, there's 3 possibilities here. Then if I expand that down, calc. Oh, I don't like calc. That's not good at all. What? Empty array. I don't like that at all, at all. 5, 10, and 11 are definitely not all found in that. What? Okay. Just take this for a second. So my A is this, and my V is this. That's working perfectly fine. So what am I doing wrong here? Something silly is almost certainly the answer. And now that, what? Oh yeah, fine. Super confused as to why this is not working now. That's kind of annoying. Okay, I guess I can just do it like this. I don't like spilling out so much, but let's just, ooh, wait, what? Oh, yeah, sorry. So now I need to text split it the other way. Good. So now we have 9 possibilities there. Then we get up to 18 here because there's the 9 can't be used, but everything else is totally new. And we can carry on. But I'm annoyed that this didn't work with reduce. I'm going to have to revisit that to try to make it work with reduce. But the answer should be columns of that guy, of that guy hash, which is 1, 3, 5, 6. And it is. But I'm not happy with that because it should have just worked with reduce. So I want to make it work with reduce. So let's come down here. So then this is the lambda. Makes everything happy. So I want to reduce this through this array. Oh, I see it. It's the, I remember I had this problem the first bloody time I did it as well. It's the merged cells. Harry. Stupid. Anyway. It's a calc error. Not good. Is that where the values are? Yes. Okay. Come back up to the top. Oh, sorry. It's because you went all the way to the bottom. Yeah, you can't do it if you go all the way to the bottom. All right. So finally, columns. Ugh. Merged cells. Killing me. Okay. There we go. So now we have a cleaner approach there. So get rid of that and get rid of this. And we'll bring this. Ooh, what, why is that number changed? Oh, sorry. 09. There we go. Okie dokie 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 dokie. Okay, just 2 more quick things to show you. One is, of course, that brings me to 1,249 points. There is one more point to be had, which is the epilogue. This is just Harry's way of making you read all the lore, I think. For an extended version of the Chapter 7 challenge, for each starting point, for each starting position in the maze that a card can't see, try calculating how many cells with odd row and column Alice can freely move within while staying out of sight. Ah, well, I think my, where are we? Hedge maze. I think my version of this would make that pretty easy with my maze lambda, because now you can just go to any unoccupied cell. So this video is already long, so I'm not going to actually do that, but I think it would work. All right, epilogue. Alice woke up in rehab with a stonking headache. She decided to leave her drinking behind her and work really hard to do the best she could for herself and others instead. She then went on to have a really successful career, but she could never quite shake the feeling that somewhere, just out of view, a grinning Cheshire cat was watching over her. To earn the last point, just write Fin in the answer box. I guess it should be fin if it's French. Anyway, that's that. Now, the original level Riddle 5 became a separate unscored final riddle. There are no points for this final riddle, and it is not part of the 40-minute challenge. This is intended for those crazies who can't quite get enough. It just says, solve the Mad Hatter's final riddle, which is over here. Alas, implied reader, Alice could not solve my riddle. Perhaps you, of a sounder mind, may have fortune reward your wit. Within my colourful trips, contained in the cells and features of this excellent Wonderland, I have come across a certain monkey, famous in some circles, but no squares, who holds your salvation. At first she thought no yellow-skinned morsels were present here, and thus had no interest. But after a cup of tea with me, she realized that I and my fellow residents are all totally bananas. If you seek her, don't not fail to muddle up the meaning of this riddle. A curse too booming drove a crazed, unmanacled Monet loopy as prime scoops go, betters treat by void without duty, and to fact-curing witches over fourscore is just kooky. Bees are all wrong, their life is Ella spooky. And I first came across this riddle when I tested this case like almost a year ago, 8 months ago, something. I know that there's a bunch of like fake things here. So like there's a hat here, and if you look at the formula text, it says she is not under my hat. And there's other, oh yeah, like if you control end to the end here, there's a thing here saying she's not down here. She's too chaotic and excitable for such a place. Let's see, are there any other comments on the page? Comments. I don't go to comments very often, as you can probably guess, but I know that there is a thing to do it. Isn't there? I'm sure there is. Have I lost my mind? Let's go to objects, I guess, but I was sure. Oh, sorry, it's called notes now. I forgot. There we go. No, there's only one note. Okay. Yeah, then is there a named range going on? Yes, there's Alas, It Was a Good Try. There's a named range called Not the Monkey. These are all mine, I think. There's stuff, if you go into the VBA editor, there's a sheet called No Lana in These Names, which is hidden. Then there's a sheet called Hidden, and if we unhide that, it says your monkey princess is in another castle. Let's see, if I say No Lana in These Names, if I unhide that, where do we get? Oh, maybe that's not a sheet. What is that? Oh, sorry, no. I just hadn't switched to visible. There we go. Had I? No, I'm confused. Maybe that's a thing that I don't know about. Anyway, yeah, then there's another one called Very Hidden. Make that visible. But again, it just teases you. Lana is not here. Maybe you could try actually solving the riddle. There's a bunch of other places where you can like hide metadata. Was there a style? No, there wasn't. Oh, yes. There it is. This style is not hiding any monkeys. There might be 20 other places. I don't know. But apparently, the answer to the riddle is Bananarama. I have no idea why. This is like the Hitchhiker's Guide to the Galaxy. It's like that's the answer, but what's the question? I don't understand. So there you go. I was able to do the rest. I still can't do that. Perhaps somebody will crack it, or perhaps not. But if you're going to try, then good luck. That's all I got for today. Thanks for watching. See you next time.